Welcome to my channel, everybody. And very interesting question is there. And here is the discussion about the inverse circular function at some point, and which is the very important for the uh, concept of like that tan inverse x plus tan inverse y. This is the formula, but the value of x when vary in the defined ranges, then there is a defined formation or we are get, and that is why it is very interesting point for the different type of competitive exam, basically to the exam of IIT advanced and main, and also the Indian Statistical Institute entrance exam. Okay, see, for the first point we want to introduce the formula is that, and this is here, let tan inverse x is equal to a and tan inverse y is equal to b. So x is equal to tan a and y is equal to tan b. So now where when x is more than 0, y is more than 0, and the point is xy is less than 1. Okay, now see, the tan of a plus b is equal to tan a plus tan b by 1 minus tan a into tan b, and that is equal to x plus y by 1 minus xy. And for that the domain of a and br lies between a comma br lies between minus pi by 2 to pi by 2. Okay, when is that? Minus pi by 2 to pi by 2. Okay, then we can write is this, but here x is less than 0 and x is more than 0 and y is more than 0 and xy is less than 1. So see, as x is more than 0, y is more than 0 and xy is less than 1, then x plus y by 1 minus xy, and this is positive, and this is a less than 1, so this is more than 0. Therefore tan of a plus b is more than 0. Okay, tan of a plus b is more than 0. So a plus b lies on first and third quadrant. Therefore a plus b lies on either first and third quadrant. Okay, but x is more than 0, therefore tan a is more than 0. Okay, therefore a lies on a comma b, tan b also more than 0, so a comma b lies between 0 to pi by 2. Okay, therefore a plus b, 0 plus 0 0 and pi by 2 plus pi by 2 pi. Okay, okay. But from that interval, we can write here at what region. So we see that this is lie on first and third, and see in that interval you see that the a plus b lies on the 0 to pi, that is 0 to this. So that's why it is lying on exactly 0 to 90. So it is exactly on the first quadrant. Okay, therefore a plus b lies on 0 to pi by 2. Okay, therefore we can write tan a plus b is equal to x plus y minus xy. Therefore a plus b is equal to tan inverse x plus y by 1 minus xy, and this is here tan inverse x plus tan inverse b is equal to tan inverse x plus y by 1 minus xy. Okay, see the solution carefully. But when x is less than 0 and y is less than 0 and xy is less than 1, okay, then a is lies between minus pi by 2 to 0, and also b is lies between, therefore a plus b lies between minus pi to 0. Now x plus y by 1 minus xy, and this is the addition of these two is less than 0 and this is here xy is less than 1, so less than, and this is positive. Okay, so whole thing is negative. So therefore this is negative. So tan a plus b is negative 0. Okay, less than 0. So a plus b lies on either on second or fourth coordinate. Okay, but a plus b lies on this. So on the second quadrant and second and fourth, and this is a minus pi to 0. So this is here minus pi to 0. So it is exactly lies on 0 to 90. So therefore a plus b lies between minus pi by 2 to 0. Okay. So now, and this is your interval when the some value of tan lies between minus pi by 2 then pi by 2, then tan a equal to x actually. So that's why we can write here. So a plus b is equal to x plus y by 1 minus xy, implies that a plus b is equal to tan inverse x plus y by 1 minus xy, and that is equal to tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy when x is less than 0, x comma y is less than 0 and xy is less than 1. Okay, when x is greater than 0 and y is less than 0 and xy is this, so therefore a lies between 0 to pi by 2 and b lies between minus pi by 2 0. Therefore a plus b lies between actually minus pi by 2 to pi, minus pi by 2 to minus pi by 2 to pi, pi by 2, sorry, this is pi by 2. Okay, so see, so in that domain, so therefore we can write here a plus b is equal to x plus y by 1 minus xy. Okay, a plus b is equal to x plus y by 1 minus xy, and that would be tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Okay, very interesting discussion. So after that we have to discuss the another interval. See the calculation here, very interesting discussion. And today is this, the next point is the second. When actually x is more than 0 and y is more than 0 and xy is greater than 1. So therefore, so in that case we have to write here a is lies between 0 to 90 and b lies between 0 to 90 if we add these two. So a plus b lies between 0 to 5. But in between what region would be perfect? That to be needed to shows that, you know, x plus y is more than 0 and y is more than 1, so that's why it is less than 0 here. So tan a plus b is less than 0. Therefore a plus b lies on second and fourth quadrant. Okay, actually now to see the region here, which is the perfect region. This is second and fourth, but does not first here. So second, perfectly second is that. See, first not possible. You see that the a plus b is lies between 0 to pi, showing that. So first and third not possible here, and it may be either fourth and second, but there's nothing the region to the fourth here, so it shows perfectly on the second quadrant. So therefore a plus b lies between, this is pi by 2 to pi. Okay, now in the interval of that we have to always convert in between minus pi by 2 to pi by 2. So that's why either doing minus pi by 2 or minus pi. Okay, if we're doing minus pi by 2, see, no, doing minus pi, so will be a perfect. So actually we want to write here, so this is 0, so this is minus pi by 2, so a plus b minus pi to 0. So see here, from that, so now a plus b is equal to x plus y by x minus y. Now see, this is right here, we have to write, actually we can write here like this is here. In case of that, so doing pi minus within the bracket a plus b, then this is 0 to pi by 2. Okay, so we can write here pi minus within the bracket a plus b. Okay, this is x plus y by 1 minus xy. See, if we write this, so needed to write as a minus of that. Okay, so in that case we can write like minus pi plus a plus b and x plus y by 1 minus xy. So this is here minus pi plus a plus b, this is equal to tan inverse x plus y 1 minus xy. So therefore a plus b is equal to pi plus tan inverse x plus y by 1 minus xy. Now see, this is a tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y by x minus y. Okay, when x is more than 0, y is more than 0 and xy is less than 1. Okay, see the calculation carefully, very interesting. Okay, and now see another point. Last point, x is less than 0 and y is less than 0. Okay, and xy is more than 0. So if x is less than 0, so a is lies between minus pi by 2 to 0 and b is lies between minus pi by 2 to 0. If we added these two angles, so it is lies between minus pi to 0. So therefore a plus b okay, now x plus y by 1 minus xy. See, this is less than 0 and this is more than 0. If we put here this is less than 0 and this is also xy is more than 1, so negative is positive. Okay, so tan of a plus b is more than 0. Therefore, a plus b lies on the either third or first. Okay, first quadrant. Now see, here is the region which I get here. So this is here. Actually, this is 0 to pi and this is 0 to minus pi here. But clearly does not lie on the fourth quadrant, and this is positive, so lies on the exactly third quadrant. Okay, so we don't get any region on the first quadrant according to the interval is here. So this is only third quadrant. Therefore, a plus b lies on minus pi by 2 to minus pi. Okay. Okay, so we get this region actually. Now see, at pi on the all the first middle part and third part. Okay, a plus b plus pi, then pi minus pi by 2, then this is a 0, a plus b plus pi, and this is pi by 2. See, so this is now the whole thing is lie on the 0 to 90. So we apply the rules here. Now I can write the basic form, that is x plus y by 1 minus xy. Now we have write this interval on that. Okay, now tan of a plus b plus pi is equal to x plus y by x minus 1. See, if we 2 into 90 of that, so it goes to a cancel. Okay, to the set, so you can write easily is that. So a plus b plus pi is equal to tan inverse x plus y by 1 minus xy. So this is here tan inverse x and tan inverse, this is here y, and take a pi to the right hand side, then this is minus pi. So this is a tan inverse x plus y by 1 minus xy. Okay, so this is when is possible when, again repeat, x is less than 0, y is less than 0, and xy is more than 1. Okay, and this domain is very interesting to solve the integral and differentiation of some interval. And now for the second. Again I repeat, let tan inverse x as theta, so x is equal to tan theta, therefore theta lies between minus pi by 2 to pi by 2. Okay, but see, when x lies minus 1 to plus 1, that is tan theta minus 1 to plus 1, therefore minus pi by 4. Okay, this is pi by 4. Therefore implies that pi by 2 theta, and this lies between pi by 2. Okay, therefore tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. This is 2x by 1 minus x square. Therefore theta equal to tan inverse 2x by 1 minus x square here. Okay, this is 2 tan inverse x. This is 2x by 1 minus x square. When okay, so see, this is a required domain, so it is exactly, this is the region. Now when x is more than 1, therefore tan theta more than 1, so theta pi by 4 more than pi by 4, so 2 theta more than pi by 2. Now tan 2 theta is equal to 2x by 1 minus x square. So from that 2 theta more than pi by 2, so this is more than pi by 2, so this is more than pi by 2 here. So more than pi by 2 means it would be up to pi. Okay, it would be up to pi. So therefore 2 theta pi by 2 to pi. Okay, so now we want to get this interval actually, so that's why doing minus pi, actually not differ pi by 2 here, so that will be a problem is there. So actually tan would be a change to the chord, so there is a problem, so we always subtract either plus pi either minus pi. Okay, so doing here minus pi. So this is minus pi by 2, 2 theta minus pi. Okay, so see, if we multiply by negative, so this is pi by 2 to pi minus 2 theta. Okay, so 0 to 90 either minus pi by 2 to 0. So from in place of that we can write here pi minus 2 theta, that is twice x by 1 minus x square. But see, here is we get a minus tan 2 theta, this is so minus minus plus. After that multiply by minus, so minus pi plus 2 theta, that is twice x by 1 minus x square. So we get there minus pi plus 2 theta, so that is equal to tan inverse 2x by 1 minus x square. Okay, so therefore 2 theta is equal to pi plus tan inverse 2x by 1 minus x square, that is equal to 2 tan inverse x is equal to pi plus tan inverse 2x by 1 minus x square. See, it's proved. Okay, these all are done. Now the last point. Okay, see calculation, very interesting calculation. Okay, so see, that is when x is less than minus 1 actually. So it is less than minus pi by 4, implies that 2 theta less than minus pi by 2. Now see here, tan 2 theta is equal to 2x by 1 minus x square. Okay, so now see, this is less than minus pi by 2. Actually this is 0 to pi and this is minus pi by 2. So this is less than minus pi by 2, so goes to this cell. Okay, this is here minus pi by 2. Okay, so that's why it goes to the third cell, lies on third cell. Actually this is less than pi by 4 to how much? Minus pi by 2. Actually this is minus pi by 2. I write that. Okay, multiply by 2. So this is actually multiplied by 2, then we get 2 theta. Okay, and added by pi. See, this is a 0 to 90. So under this domain, so now replace in that case 2 theta plus pi. That is twice x by 1 minus x square. But it is right or not? It is right not. It is 2 pi plus theta. It is 2 pi plus theta. Okay, right. So 2 theta plus pi is equal to tan inverse 2x by 1 minus x square. So 2 theta is equal to minus pi plus tan inverse 2x by 1 minus x square. So 2 into tan inverse x is equal to minus pi plus tan inverse 2x by 1 minus x square when x is less than minus 1. Okay, I think all of you better understood, and this is the very interesting discussion today, and this is the more expensive for your education. See carefully. Okay, now we have to do the integral. Okay, if you knowledge about that, so you can take easily to solve this question here. So this is a tan inverse 2x by 1 minus x square dx. So under this case, and this is a less than minus 1, so you can take here root 3 to minus 1 and write here tan inverse 2x by 1 minus x square dx. After that, this is here minus 1 to plus 1. Okay, again we write here tan inverse 2x by 1 minus x square dx, and after that 1 2, and it is a root 2, and this is more than 1, root 3, and this is tan inverse 2x by 1 minus x square dx here. And now this is minus 1, okay, and this value is equal to, lies on what region? Less than minus 1, okay, so less than minus 1, okay, this is your region. So this value is equal to pi plus 2 tan inverse x, okay, and minus 1 to plus 1, this is equal to only 2 tan inverse x and dx, and 1 to root 3, and this is more than 1, this is equal to minus pi plus 2 tan inverse x and dx, and now need to integrate actually tan inverse x and dx, and this is equal to tan inverse x and dx means x here. If we differentiate this, then we get there 1 plus x square, integration of dx is x here, and dx, so x tan inverse x and half of ln 1 plus x square plus c. So that's why we take as a pi and minus pi. Pi dx is x, and this is a minus root 3 to minus 1, and also minus pi x, and this is a 1 to root 3, and now we have the integration of that is here x tan inverse x half ln 1 plus x square, and this is minus root 3 to minus 1, and also that here is, you can write here 2x tan inverse x minus half ln 1 plus x square, and this is values here minus 1 to plus 1 here, and the third part is that 2 into x tan inverse x minus half ln 1 plus x square, and the value is here 1 to root 3 here. Okay, well done, very interesting question, and you can easily put the limit here and solve it carefully. Okay, bye everybody.